Hello folks, my name is Dr. Zac Hildenbrand. I'm here with my colleague Dr. Kevin Shug, and we are the Collaborative Laboratories for Environmental Analysis and Remediation at the University of Texas at Arlington. We're coming to you from the Responsible Shale Energy Extraction Conference, which is a very unique event bringing together scientists, concerned citizens, operators, regulators, and technology companies to have an honest series of conversations about environmental stewardship in shale energy.
We'd really like to thank the support of the Cynthia and George Mitchell Foundation in Earth Day, Texas for allowing us to put on this event. We believe that this content that we're going to be providing to those who haven't been able to attend is going to help answer and educate a lot of questions surrounding responsible shale energy extraction. So we hope you enjoy the content.
Good morning, everyone. Thank you very much for joining us. My name is Dr. Zac Hildenbrand. I'm here with my good friend and colleague, Dr. Kevin Shug. We are with the Collaborative Laboratories for Environmental Analysis and Remediation, also known as CLEAR, with the University of Texas at Arlington. And we're here today at the first annual Responsible Shale Energy Extraction Conference. When Kevin and I were thinking of this conference and conceptualizing how we would put this on, we really wanted to have a collaborative environment where we can bring various perspectives, scientists, concerned citizens, regulators, oil and gas operators, service companies, technology developers, to come together to have an honest series of conversations about shale energy extraction. Too often we see a lot of these conferences are very polarizing on one side or the other, and we wanted to bring all those perspectives together in a neutral ground to open up new partnerships and collaborations.
So, I think I'm on. I'm not on. It is. Okay. All right. We have this one. All right. Sorry. A few technical difficulties to iron out here. Just so you know, again, I really appreciate you being here. It's, I guess, a feat that you did find your way here, because as we understand, some people are lost walking around the fairgrounds trying to find the way here. So we also understand that Secretary Perry's running a little bit late, so we're just going to do a quick little switch of the schedule here, and Zac is going to give his talk first, and then we'll continue on with the regular order after that. Just a couple of housekeeping issues. Please silence your cell phones as usual. In terms of question and answer session, obviously we want to encourage as much dialogue as possible. The way that we'd like to handle questions is, if you have a question, please, and you can raise your hand at any point during a presentation. In fact, we encourage you to do this before the end of the presentation. Raise your hand. One of our attendants will come and bring you a note card where you can write that question down. They will deliver that to us, and we'll collate those and have those to ask for each of the speakers. No questions are off limit. Obviously, we only have a certain amount of time to answer any of the questions that we have. Anything that doesn't get answered, we'll do our best to answer online following the conference. There's obviously a lot of extra information posted on the website. There's schedules available if you didn't get one. We do have those printed out. And obviously we'll have some breaks also for interaction with speakers. So really hope you enjoy this session. I think we have a wonderful lineup. It's really our pleasure to organize this, and I think we'll get started then.
Yep, absolutely. Thank you. Here, why don't you, Bruce called me. Okay, we can go ahead and roll that presentation. All right, so I'm going to talk a little bit about what is unconventional oil and gas development and what do we know so far. So, unconventional oil and gas development, there's actually nothing unconventional about it. It's been around for quite some time. It's certainly been optimized, and some might say perfected, in the last 30 years. But what they're talking about is unconventional. They're talking more or less about the formation, permeability, porosity of the formation where they're extracting these hydrocarbons for. So that's the difference of conventional versus unconventional. But what we're talking about here, most people think that unconventional oil and gas development, they use the terms hydraulic fracturing or fracking interchangeably between those two. And actually, we know that unconventional oil and gas development is much more articulated. There's a lot of sub-processes that are involved. Basically, I'm going to break it down into 3 phases. So you have the drilling phase, and basically this is where they're drilling the wellbore and they're putting down various layers of protective casing, protective cement. So this is basically to protect the groundwater, the aquifers, from the process that they're passing through to get to the hydrocarbon layer. Then you have the stimulation phase, and the stimulation phase can be done either by hydraulic fracturing, which again people use the term fracking, or shale acidization. So fracking requires millions of gallons of water. You have sand as a proppant to open up the fissures in the shale formations. And then there are some chemical additives that are used. Shale acidization is a little bit different, where you're using acids to basically dissolve these hydrocarbon layers to relinquish those previously sequestered hydrocarbons. And then there's the production phase. So now you've drilled the well, you have stimulated the well, and now you're pulling up your hydrocarbon product, whether this is natural gas or oil or a mixture of the two. And what also it needs to be considered here is the management of these resources. So if you are acquiring large amounts of oil, then in some cases they are burning off the natural gas and then managing that product. And then also you have the waste. So you're using this water and these additives to stimulate this formation. Some of that material comes back up, and so how you handle that waste, as you can imagine, there's a lot of variability in industry, but there are certainly some more responsible manners to do this. What are some of the environmental concerns? Again, when it comes to fracking or unconventional oil and gas development, you hear a lot of polarizing debate about this. Again, we're a neutral research entity, and I can assure you we don't get a whole lot of Christmas cards in the mail. And it's not because we don't celebrate Christmas, it's because we get it from both sides of the argument because this is such a contentious topic. So some of the environmental concerns that people will voice, you have issues about groundwater quality. Again, you are acquiring hydrocarbons, oil, natural gas, and you're using chemical stimulants to do that. There are concerns that some of those products may get into the groundwater. Then also you're talking about surface water. Again, the management of these fluids as they go up and down the wellbore, if that's not done responsibly and appropriately, then you can have surface water contamination. Concerns about air. You're going to hear a number of presentations today talking about air being affected by irresponsible shale energy extraction, which can occur, and surface spills can contaminate soil. We have people who are concerned about the human health implications, which we're going to hear from some experts today about that. And then again, chemical contamination in industrial fluids. This is an industrial process, and just like any industrial process, there are opportunities where things can go wrong. But the purpose of this conference, for us getting together today, is to illustrate that unconventional oil and gas development can be done responsibly. Not every operator does it responsibly, but there are a lot of good operators out there, and so what we need to do is talk about the differences between responsible and irresponsible drilling, so that if we can make this a sustainable practice, then we need to be doing it with environmental stewardship in mind. So I'm going to talk a little bit about our research. We've collected thousands of groundwater samples all across the state of Texas, Louisiana, Pennsylvania. We've had the pleasure of interacting with many families, hearing their stories, and you're going to hear from some scientists today talking about the societal implications and perspectives on drilling. But we started basically in 2011 as basically a side project. I was a postdoc at the time at UT Southwestern, and we kept hearing on the news all the time that, well, there's fracking. It's harming animals, it's harming people. People are concerned about it. And on the other side, everyone loves the financial implications of it, and there are no contamination events. So varying perspectives again. And so in 2011, we just looked at the peer-reviewed literature and saw, is there any science on this? I mean, clearly, if this is on the news all the time, then there must be a lot of literature that they're basing these opinions on. And we were really shocked to find that in 2011, there was absolutely nothing. So we actually, in a very, no pun intended, unconventional fashion, scraped together money from 4 of us to go out, collect samples from 100 private water wells, screen those for a panel of metals, minerals, and chemicals, and that was basically the start of this research. And now we do this full time. We're able to help a number of families who have concerns about this, communities, and our research is really growing to the point now that we're also developing remediation technologies to help folks when things go wrong. So one of our first papers we actually published, we had an opportunity to go out into West Texas, and this is in Sweetwater, Texas, where they have the rattlesnake roundup. And again, I'm not from Texas, as you can understand from my accent, but it seems like Central Texas to me, whereas they call it West Texas. Nonetheless, we were able to collect samples before, during, and after the expansion of unconventional drilling in the area. So here you see, this is just a random area, and it was a beautiful series of ranches out there. It's quite lovely. And then, so this is 2012, and then later, a Google Earth image of 2014, where some of the activity had moved in. And what we found was really quite interesting. Again, we had collected our first set of samples in December of 2012, where there was only one unconventional well in the area, and coincidentally, we did not find any volatile organic compounds in the water, we didn't find any bromine in the water, and we found a neutral pH. And as time went on and we had more wells in the area, we found that there were some chemical additives in the water. As you went on with more rigs in the area, more operations, we saw more diversity in these compounds in the water. And changes in pH, changes in bromine, total organic carbon. And again, this was an example where you had some operators that were not operating responsibly. And in this case, we were able to provide this information to the landowners, and they greatly appreciated that, and they took that into account in terms of how they're going to manage their ranch moving forward. We've also done some research. You're going to hear from Dr. Guido Verbeck. He has what I call a magic machine. It's a magic car. And basically what it is a hybrid vehicle where you have a mass spectrometer in it. And you can actually collect air quality measurements in situ driving 70 miles an hour. So what we did is, and it plots the data on a Google Earth map. It's really quite phenomenal. So what we did is we had access to some pad sites down in the Eagle Ford Shale where we were able to drive this car. And we drove it over the whole region, but also onto some of these pad sites to see, are there components of this process that are particular bad actors in terms of contamination. So here we have benzene emissions, and we have concentrations from 0 all the way to 1,000 parts per billion. And we drive this car all around, and as you can see by this heat map rendering, we found 3 particular components here that were contributing to benzene emissions. We found it was a flaring station, we found a hydrogen sulfide scavenging unit, and we found a compressor unit that was contributing to benzene emissions. What was very, very interesting and incredibly valuable is that this level of contamination is certainly not occurring on a systematic level. And that's very encouraging. So again, we went to some other pad sites, same anatomy, same production, same process, and as you can see here, we didn't find anything on this pad. That was very, very encouraging. We went over to this pad and found, again, a hydrogen sulfide scavenging unit that was contributing benzene. We're looking now at xylene, and again, benzene, toluene, ethylbenzene, xylene, they fall under a class of called BTEX, which are co-contaminants of petroleum compounds. And so they're more or less a harbinger of other contamination, if you will. But if we look at xylene, again, same type thing. We have this flaring station, this hydrogen sulfide scavenger, and then this condensate compressor unit that is contributing to xylene. We go back to these other wells, and no such issue here, but we have this scavenger here. And what we were able to find out is, interestingly, here they had a BTEX-based hydrogen sulfide scavenger. They had BTEX in that solvent, whereas this unit here was alcohol-based. And so what we were able to say is, and this one was BTEX-based as well, so what we were able to say actually to the landowner, who then put us in contact with the operator, is hey, this pad, a couple of these pads look really good, but you have some issues with these other ones. Why don't you swap out these hydrogen sulfide scavengers to put the alcohol-based component in there? They did that and they cleaned it up. So that's encouraging. That's how we can use science to make this a cleaner process. It's exactly what we wanted to do. Now, we also were looking at, okay, on this particular ranch, we already know that there are air quality issues here. Are those air quality issues percolating into the soil? That's a pertinent concern. I mean, this particular series of families, they raise Black Angus beef. And so theoretically, if it's in the air, could it be getting into the soil? Could it be getting into the grass and maybe into the beef? We don't know. So that's what we wanted to analyze. And what we found was very interesting is that here we have concentrations of total BTEX in the soil from 0 to 6 parts per billion. We're not looking at very high concentrations. And that's because, again, these compounds are in the air. They may percolate down into the soil, but they're also going to get volatilized by the sun and the wind, and they're going to blow all over the place. So again, not very high concentrations, very low levels. But what we found is, when we collect samples from the pad sites, they have a very, very firm caliche soil that those chemicals essentially just go onto the surface and then they get baked off. When you go off of those pad sites, you have the softer soils where they can concentrate. And so, again, this is information that we're helping ranchers help with their ranching lifestyle. They take this valuable information and they can adjust how they operate their business. And so we also provide this information to the operator, and it can help them clean up their process. So really quite fruitful. We also did another study, which you're going to hear from Dr. Bryce Payne today, where we used another mobile technology looking at methane. And here's a quick snapshot from that paper where driving the car around, and as got closer to some of these compressor stations, you see massive spikes in methane. And again, sure, that could be perceived as bad news, but we look at it as this is an opportunity that this is a mechanical failure, perhaps, that we could address. You identify the problem, and then we can provide a solution. And so that's how we're supposed to use science in this society to improve our lives and make informed decisions. It's also really important, it's certainly not enough to identify problems. You can't go around identifying problems all day. You also have to provide solutions. So this is something that we are really, really interested and excited about in some of this recycling and remediation work. So here you can see this is what irresponsible shale energy extraction may look like. So here are waste pits where they have this fluid that's come up the well, and they just dump it in this waste pit for it to essentially evaporate. That's just not a responsible way of doing it. Especially when you look at that same waste pit 3 months later where they just pulled the tarp out and let those fluids leak into the ground. We actually were able to sample this and sample a little pond next to that pit, and as they pulled this tarp out, those chemicals were found in that pond. So again, not responsible, but not everyone is doing it like this. In some of these cases, these are smaller operators that when no one is looking, they just try to get the job done, and that's just not a sustainable and renewable way of going about things. So what we're looking at is we're developing these new technologies with various companies, some startups here, looking at thin layer carbon graphene as a filtration device. We're looking at new filtration devices with Asahi Kasei, a massive company in Japan. They're probably most famous for doing all the filtration of all those delicious beers over there. We're also looking at some photo degradation with catalysis and enzymes. There are enzymes that you can harvest from certain bacteria that love to eat carbon materials that we can actually use to break down some of these compounds. And lastly, you're going to hear from Dr. Inez Santos today. She's discovered that when you have contamination events with some of these carbons, it actually recruits a lot of pathogenic bacteria which love to eat up those compounds. And so to treat these bacteria, these are actually resilient to high levels of chlorine. They're resilient to an autoclave, and in some cases, they're resilient to UV. So this may sound like a little bit of weird science or something out of the movie Super Troopers, but not Super Troopers, Starship Troopers. But there are actually viral particles known as bacteriophages that they selectively target their host of interest. They lyse those bacteria, and then from there, once there are no more bacteria, they go away. They're totally innocuous to humans. They have no effect. And so our thought is, once we do our elaborate bacterial scan, then we can decide, okay, what bacteria are there. We can design a phage cocktail for pennies on the dollar, treat the water, and within seconds, all those bacteria have been lysed and destroyed. And those bacteriophages have no effect on humans. So it's a little bit of weird science, but we're trying to think outside the box on some of this stuff. Again, collaboration is absolutely critical. This is something that we're extremely proud of in our work that we're doing in the Balmarais, the Alpine High as it's known, our collaboration with the Apache Corporation. And through this collaboration, they have found us well sites to test. They have provided us with chemical disclosure information to know what we should be screening for. And this is a company that is really concerned about environmental stewardship and understands that they cannot compromise the land in the event, in an effort to acquire hydrocarbons. It's just not a sustainable practice to do that. So they understand the value of protecting the environment. And so we have a one-year monitoring project that we're hoping to extend on for a longer period of time, going out there. It's been a really rather controversial topic, I guess, because of the Balmarais State Park there and the springs. It's a really ecologically sensitive area, but we have all our hands on deck here, and this collaboration I think is going to be, it's groundbreaking in many ways, but we're hoping that it will pave the way for other scientists to collaborate with industry in a beneficial way as well. So again, if anyone has any questions, thank you very much for this opportunity. This is something that a lot of us have poured our lives into, and we really see that we are making a difference. And recently, our research group was nominated for the Humanity and Science Award, which is something that is near and dear to our hearts. So we want to keep doing this and making a difference. So thank you very much for your time, and enjoy the rest of the conference. Questions?
So again, if you have some questions, please raise your hand, and we'll be able to bring around a card to you. We have a couple minutes for questions, and I have a couple of questions here that have been passed to me. So just for one, I mean, could you please just explain the value of a time course studies versus one-time data point study?
Yes, absolutely. So the value of time course testing and actually getting preliminary baseline testing is you have a value that you can refer to before there's been any anthropogenic activity in the area. So preferably when you get into an area like, let's say, Balmarais, which is about to expand with a lot of activity, you want to go out there and collect samples to look at what the groundwater and the environment looks like before that activity takes place. And then as you follow up with subsequent measurements, you can see if those activities have had any effect.
Okay, thanks. Oh, now I'm on. And now I'm standing right in front of this thing, which is all right. So what do you think are the essential types of sciences that should be used to understand the impacts or potential impacts of oil and gas extraction?
So it actually requires a multidisciplinary effort. I'm a biochemist. Kevin is a world-renowned analytical chemist. We have hydrogeologists, soil geologists, we have biologists, field biologists, statisticians, quantitative biologists. It requires a multitude of expertise to come together on this. And that's why it's so difficult. You also need to interface with people in the community. I have the benefit of being, a friendly Canadian that doesn't like guns, so I show up and I'm totally unassuming and no one fears me. So I'm able to have a nice in with people, they trust me to test their water. But there's a lot of factors that are involved there.
Okay, and let's see, maybe a final question. So as the research world focuses more on self-promotion, how do you think you best spread this information publicly? Should it be peer review, blog, straight to the news?
So all of our research goes directly to the peer-reviewed literature and gets analyzed by our respective colleagues in the industry and in this field of research. And then once that research has been published, we go out into the community, we do town hall meetings, people have questions about this. For example, in Balmarais, we've gone out a couple times with Apache, given presentations about what's going on in the community to put people's mind at ease as to what's going on. And in those opportunities, there's no question that's off the table. And again, we're just trying to inform people as to what's going on, what research is being done, and address their concerns.
So let's thank Dr. Hildenbrand one more time for a very nice talk.